In today's class, we will see about Coulomb's law. Let us read the statement. The force between 2 point charges is directly proportional to the product of the magnitude of two charges and inversely proportional to the square of the distance between the two charges. The force along the line joining the two charges. Let us try to understand this. The force between 2 point charges. If we have 2 point charges, say Q1 and Q2, Q1 and Q2, the force between them is directly proportional to the product of the magnitude of two charges. If I take the force as F, it is directly proportional to product of the magnitude of the charges Q1 into Q2. Let us take this equation as 1. And inversely proportional to the square of the distance between the two charges. The force is inversely proportional to the square of the distance between the two charges. Let us say the two charges are separated by a distance of r. We can write the force is inversely proportional to square of the distance between the two charges. If I combine equation 1 and 2, I can write the total force. So total force is directly proportional to the product of magnitude of two charges and inversely proportional to the square of the distance between them. And this force acts along the line joining the two charges. F is proportional to Q1 Q2 by R square. Now we will equate this equation. We will take some proportionality constant and then we will write what is F. So in air or vacuum, the forces can be written as F is proportional to, so let me equate it into some K. K is the proportionality constant. F is equal to K into Q1 Q2 divided by R square. Now what is K? Where K is given by some constant. K is a constant given by 1 by 4 pi epsilon naught, where epsilon naught is, this is also some constant, 8.854 into 10 to the power minus 12 Coulomb square per Newton meter square. And this is known as absolute electrical permittivity of free space or vacuum. Epsilon naught is absolute permittivity free space. Absolute permittivity of free space. Now if you substitute epsilon naught, you will get K as 9 into 10 to the power 9 Newton meter square per Coulomb square. For all your problems, you can take this value. K is 1 by 4 pi epsilon naught, which is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Here onwards, for any problem, if you get the quantity 1 by 4 pi epsilon naught, you can directly substitute it as 9 into 10 to the power 9. This is if this force equation holds good if your charges are placed in air or vacuum. Now, if the charges are placed in some other medium other than this air and vacuum, what will happen to the force equation? In any medium, you can write force as one by 4 pi epsilon naught into epsilon r into q1 q2 divided by r square. We have another extra term here called epsilon r. So this epsilon r is relative permittivity or dielectric constant of the medium. Epsilon r is called the relative permittivity, or it can also be called as dielectric constant of the medium. Dielectric constant of the medium, or it can also be called as relative permittivity, and it is a unitless constant. It is dimensionless and unitless constant of the medium. Dielectric constant epsilon r is relative permittivity, so it is dimensionless and unitless. Next, let us try to write Coulomb's law in vector form. Coulomb's law in vector form. Let we have 2 point charges q1 and q2 with a separation r placed in vacuum. 2 charges q1 and q2 with separation of r in vacuum. The medium which I am using is vacuum. So the magnitude of force is given by Coulomb's law. One by, just now we have seen the equation, 4 pi epsilon naught into q1 q2 divided by r square. Now first we'll write the vector equation for like charges, and then we can go for unlike charges. Like charges. Let us take 2 charges are positive, plus q1 plus q2. In vector form, force on q1 due to q2 can be written as F12. And because these two are like charges, they repel each other. So force on F1 due to F2, the direction, if you want to mark, the direction of the force is along the line joining the 2 charges. So it will be like this: a repelling force acting along the line joining the 2 charges. We can write this as F12. The direction is as shown here. Let me take this distance vector as R12. Or 2 to 1, so R to 1, because we are taking a force on Q1 due to Q2. R to 1. Now F12 can be written as 1 by 4 pi epsilon naught into Q1 Q2 divided by R square into R21, where R21 is a unit vector given by vector R21 divided by magnitude R. This is how we write in vector form. We will multiply by the unit vector. Similarly, force on charge Q2 due to Q1 can be written as Q2 due to charge Q1, that is force on 2 due to 1, F21, can be written as 1 by 4 pi epsilon naught into Q1 Q2 divided by R square into R12, unit vector R12, where R12 is the vector R12 divided by R. Let me show you this in figure. We have two charges plus Q1 plus Q2. We have to calculate force on 2 due to 1. So now let us mark this distance vector as 1 to 2, R12. Force on 2 due to 1, so distance vector from 1 to 2 is R12. And this force, it's a like charges, so repel each other, and the force is acting along the line joining the two charges. F21 will be acting as shown here. So we know R12 is equal to minus R21. Vector R12 is equal to minus R21. Therefore, the force F12 will be always equal to minus F21. This proves the electrostatic force follows Newton's third law, because force on both the charges are equal in magnitude but opposite in direction. It follows Newton's third law because force on each charger are equal in magnitude but opposite in direction. For like charges, the magnitude will remain the same, only the direction of charges will change. For unlike charges, now if we have one positive charge and one negative charge, there will be a force of attraction. Q1, and let us take minus Q2, unlike charges. Now force on 1 due to Q2 will be acting like this, and force on 2 due to Q1 will be acting in this direction because it is attractive force. So this is F12 force on 1 due to 2, force on 2 due to 1. F1 to F21. And the magnitude is same as the before equation. F12 is 1 by 4 pi epsilon naught into Q1 Q2 divided by R square into R21. F21 is 1 by 4 pi epsilon naught into R12. Same as these two equations, F12. This is how we write Coulomb's law in vector form.